The FIA has now released their 2026 Formula One car renders, and they're pretty interesting. So I thought we would make this video just to walk from front to back on the car and talk about what some of the aerodynamic features might be doing. Start here at an image of the front wing. I think this is one of the really interesting parts of the car. It's a bit of a throwback to some of the older wings of previous generations where you have a nice little foot plate. So if I use my highlighter here, you have a nice little foot plate here. You also have a front wing end plate, which is actually inboard on the inboard side of the front tire instead of the current generations of the front wings, which extend all the way out to the outboard side of the front wing. So that's certainly an interesting feature. You also have a distended nose or disconnected nose from the front wing elements here. You can see there's actually a few pylons which are lifted up like this, which bring the nose up higher than the actual front wing itself. That allows some air to get underneath the front wing like this. But if we look at some of the specific features of the front wing, the first thing that jumps out is really this very interesting little foot plate that we have here. And what you're going to actually generate inside of this foot plate is a foot plate vortex. And so that foot plate vortex is just going to help a little bit to maintain a bit of the suction that you're going to need to have underneath this front wing here. You're going to still have what's called a corner vortex. So let me just go ahead and draw that. You're going to get a little bit of a corner vortex, which is going to form right here in this corner. And then you're also now on this front wing, there's a little wing strake that's right here. You're going to have a little wing strake vortex here. And then you're also going to have what's called an end plate vortex, which is going to kind of form off the backside right here. So all these vortexes, interestingly enough, are rotating in the same direction. So they're all sort of moving in this anti-clockwise direction as we look. So I think it'll be really interesting to see what happens with these vortices if they actually merge as they move downstream. For instance, you have two co-rotating vortices and you have two singular vortices that are next to one another. Well, as you move downstream, they may become, say, one big vortex, right? So that'll be interesting to see is how these vortices kind of are behaving. I see this as being a really interesting part of technical development on the cars and how they're sort of managing these vortices. But one interesting thing about these vortices as well is that they could be actually helping a little bit with a tire jet. So on the bottom side of the tires here, there's going to be a tire jet or tire squirt, whatever they might call it. And as you have air that's rotating from this, say, front wing end plate here, it's going to be downwashing some air onto this tire jet, and it could help to sort of suppress this tire jet a bit and keep it lower because we're not going to want this tire jet obviously going into our floor system here. So for that reason, engineers might be able to design this particular areas right here in the corner vortex, the footplate vortex, to help a bit with that tire jet that might be there. Another feature that I wanted to talk about is kind of all of the vortices that are coming off of the upper and the lower vortices, which are coming off of this. That's not a real good color there. Let's use a different color. So all these upper and lower vortices, which are coming off of the top of and the middle of the wheel of this tire as well, and how potentially these sort of the strake vortex that's being formed here in this end plate vortex might interact with some of these tire vortex features. The thing is that this particular little front wing, little winglet right here is actually going to create for you a little bit of load as well. So you're going to use this to create a bit of downforce here. So we all know that you're going to create a lot of downforce from this front wing. And actually one of the things to notice is that ground proximity of this central section is much closer to the ground than it is as you get outboard here. So your ground effect in this central part of the wing is going to be much higher. You're going to have much higher suction than you will as you sort of move outboard a bit there. So that will also affect the trajectories of the air and how the air moves as it comes off of this front wing and now interacts with the rest of your car. This is another good shot here just to kind of see the way that all these different features are going to be interacting. So again, if we're talking about the front wing here, you can see you've got a nice little winglet. So what that's going to do is that's going to sort of pull some air up like this, and then you're going to be able to generate a bit of downforce from that little winglet there. So that'll be a nice little feature. I did mention that you've got the tire jet, which is sort of developing down here. You've also got these wheel covers, which are going to try to suppress some of that wheel vortex, but inevitably there will be some there as well. And then you're also going to get a bit of vorticity, which is going to come off the top portion of the tire here. And as I mentioned before, interested to see how this vortex is going to be forming here from the end plate is going to maybe help to try to, say, suppress some of this vortex and keep it down. As we can see, we've got a little wing feature here. So this is the outer portion of the floor entry here. So you've got a nice little floor entry wing. The only problem with this entry wing is it's actually inwashing, so we have a better view of that in another image. But all of these vortices, all these green little vortices, which are going to be coming off of here, whether the lower ones, the mid ones, or the upper ones, are going to want to sort of gravitate down into this floor. So obviously that's not a good thing, because these wake structures have, as I mentioned, low energy or low CPT relative to the free stream, which means that you're not able to do a lot with that kind of air. You can't extract that energy and turn it into downforce. Now, another point just to make here is around what we have with kind of this generic side pod design. So they sort of have this side pod going back like this, and they have a nice little undercut which kind of goes like this. So obviously I think this is going to be an area where you're going to see a lot of teams developing maybe some downwashing concepts that might occur like in some of the cars that we have now, with some features in how they're managing the undercuts. So lots of development I think there, as well as some key development areas around here on the floor edge, probably some opportunities to put some little small floor edge wings, and if you say design this side pod in such a way that you can generate a bit of outwash, although they might be controlling that because they don't want to generate outwash, that's the whole purpose of the regulations, then you might be able to put some little flick ups or some little features here on the floor edge, and potentially some rear structure so you can pull some vorticity or some energy into the rear of the floor as well. This is the other render image here where you can again see this little front wing, distended wing strake. Again, this is where you're going to get that kind of rotating vortex, which is going to come off of here and rotate down and maybe interact with the mid portion of the wing, and then you're going to get your foot plate vortex in here, which is then going to translate down this way. But what I wanted to show is just this feature here where you've got this outer fence, and it's actually inwashing. So as the air is coming, you can kind of see it's got a curvature which is pulling the air this way, right? So it's going to be pulling the air down into the body, and naturally you want to try to get some of this front tire wake that's going to be coming off of here, and you want to try to keep it outboard, but I'm not sure they're going to be able to do that just because of how far out this is, and it definitely seems like the FIA is trying to prevent as much outwash as possible. So a lot of this low tire wake energy is probably going to be ingested into the floors themselves. And we do have some floor fences, which are now there in the particular renders, which we'll talk about in a moment. But that's one of the main things here. Now you can also see that there's there's very little detail along this floor edge here, and that's because, well, it's a completely undeveloped car. It's just a Formula One model. So I see this as being a key area where teams are going to be focusing their time, as well as how to generate some downforce there, maintain some edge load from the floor edges. The other thing is that if you look at the rear wing, you can see it's now kind of this tetrahedral design like this. So it's similar sort of to what we've seen in the past from other teams where we have sort of this spoon wing shape design. And that just simply will help a bit with sort of the inboard loading to the outboard loading, but also it's different flow trajectory profiles as the air is coming over the body itself here. You have kind of this downwashing body where you're able to generate a bit more load on the main plane than maybe out here where it's more unaffected by the body, so you have to run a different leading edge angle. So that could also be part of the reason why that's there. So I mentioned the floor fences. You can see them really well here. So you have 1, 2, 3, 4, 5 floor fences which are showing up here. They're quite cambered. They're angled very heavily. And that's because, obviously, well, this is just a render, but that's because the length to which, if you look at the underside of the floor and it sort of looks like this, and maybe this is the whole floor body, the regulation box in which you can actually have the floor fences is extremely small. So if you want to get any sort of vorticity that you could bring into the floor itself, then it's going to have to be highly cambered over very short distance to generate some of that vorticity. So I think maybe that's what's going on here possibly, is that you've got a bit of this sort of highly cambered floor fences, which should then maybe generate very small discrete vortices which will enter into your floor section and help to reduce the pressure in the floor section. So that's a bit about kind of the floor fences. I really don't think they're going to operate or work as well as they are currently in the ground effect era floors. But it is still a very important feature because you've got this front wing here, which is going to have a bit of a more shallower profile in terms of upwash in the central nose section, but you're going to have big upwash. You can see here from this front wing itself. So the air is going to be disturbed and moved up high, and you're going to need to bring a lot of high energy into the floor here. Even though they are flat-ish floors, so they're not completely flat, they're raised slightly from everything I've been told, but they are not Venturi style floors. So certainly these floor fences just, I believe, are just there just to aid and help a little bit in bringing some vorticity into the floor system. But you do notice that previously the brow that was here, kind of the wheel brow that was previously here, that was helping to suppress kind of that vortex that you would generate off of the top of the tire here, is gone. We've seen many times that they get broken and they start flapping around or they fall off as well. So I think maybe that might have been the FIA's attempt to just kind of clean that up a bit. I think this is a really interesting part of the car. This is the rear portion of the car that you see here. So for me, yeah, when you look at this, you can clearly see that, in one point there is no beam wing. So you look over here, there is no beam wing, and over here you see there's a beam wing. So everything that I know that I've been told is that there will be no more beam wings. But you can see that maybe in one of the older renders or newer render or something, potentially they might have included a beam wing. So this is possible that beam wings, maybe are coming back possibly. I don't think so, but it would be really interesting nonetheless. But another thing is, actually you look down here, you can see, here's the volume of the diffuser, which is right here. Okay. Actually, let me just trace that out for you right there. This is the volume of the diffuser right here. Okay, and then you see there's a really interesting something sort of sticking out like this, right? And then there's another little extended feature which kind of goes out like this. So what is that? Well, it could be a couple of different things. They could have maybe added some kind of like a protector fence or deflector plates or something like that to just kind of protect the diffuser from some of the vorticity which is coming off of the lower tire jet, which is here, and just preventing it from coming inboard into the diffuser. If it if you bring those low energy structures into the diffuser itself, it will obviously rob your floor of a lot of the performance that you could have. Um, but interestingly, it looks a lot like we used to have these brake drum deflectors, which were right here, and it almost looks like the brake drum deflector is sort of hanging off the side of the diffuser, which would be really odd if that was the case, because as far as I knew, what they were doing previously, with the tires and the brake drum deflector here with all the little slots that were in it, was they were attempting to, do a couple things. So you would get this tire jet, which would form here off of the tire itself. And then as the air is coming through, it's hitting this drum deflector and it's being upwashed. So you're naturally then from that generating a bit of downforce locally, which is attached directly to the rear hub there, which is a really good downforce. But then I think what it's also doing, or what I think it was doing previously, is it's helping to sort of lift this lower tire jet that was right here and sort of relocate it a bit higher, which is important because the diffuser wall itself only extends down till a certain point. And that diffuser wall, obviously can't touch the ground. It can't make contact with the ground. So as low as it can be to help protect the diffuser is great. But, there's still the possibility that some of that might migrate itself over into the diffuser, in which case then you want to have kind of this brake drum deflector, or this deflector, which actually helps to sort of lift that up a bit higher. So now it's being barricaded by the diffuser wall itself. So it's possibly something going on with that. Would be really interesting to see if that makes its way into the final regulations, or if that is a specifically a specified feature that comes from the FIA, or if there's a bit of freedom for teams to be able to operate. So hopefully everybody's enjoyed this video. I just wanted to talk about some of the features from what I saw from the latest render updates, and be sure to follow along for more in the future.